The Karun River is the lifeline of southwest Iran. For decades, it has supported agriculture, cities, industry, and fragile ecosystems. Yet today, the Karun is under stress. Reduced base flow, unstable water levels, drying floodplains, rising salinity, and severe dust storms have become part of everyday life in Khuzestan. Traditionally, large dams were seen as the solution. But with advancing science and technology, a critical question emerges. Is building new mega dams still the smartest way forward? Large dams brought undeniable benefits: hydropower, flood control, and water storage. But they also introduced serious challenges: abrupt flow fluctuations, sediment trapping, high evaporation losses, ecosystem fragmentation, and downstream degradation. In rivers like the Karun, the problem is no longer water capture. It is flow stability. Modern river engineering focuses not on dominating rivers, but on regulating them gently and continuously. Around the world, a different approach is gaining ground. Inflatable rubber dams, flexible, low-height, adjustable hydraulic structures. Unlike concrete mega dams, rubber dams do not create massive reservoirs. They regulate water levels locally, seasonally, and reversibly. They can be inflated during dry periods and safely deflated during floods, allowing the river to pass naturally. This approach transforms one large hydraulic shock into a series of small, controlled adjustments. Using a simplified numerical model based on HEC-RAS, we simulated a pilot reach of the Karun River. 3 scenarios were compared: the current condition, a hypothetical new large dam, and a chain of 5 inflatable dams spaced along the river. The results are clear. The inflatable dam network reduces water level fluctuations by up to 60%, lowers peak flow velocities by 30 to 45%, and increases dry season base flow by more than 25%. The river becomes calmer, more layered, and more predictable. Dust storms in Khuzestan are not just a meteorological issue, they are a hydrological one. Dry riverbanks, exposed floodplains, and disconnected wetlands are the primary sources of fine dust particles. By stabilizing river levels and increasing base flow, inflatable dams keep adjacent soils moist for longer periods. A coupled hydraulic soil dust model shows a 35 to 55% reduction in dust emission potential, particularly affecting cities like Avaz, Abadan, and Khorramshahr. In simple terms, controlling water flow means controlling dust at its source. Each inflatable dam can be equipped with a small hydropower unit, with heads of just 2 to 4 meters and high river discharge. Each site can generate between 1 and 3 megawatts of clean electricity. A network of such structures can produce up to 50 megawatts without large reservoirs, resettlement, or ecological disruption. At the same time, stable water levels improve irrigation reliability. reduce soil salinity, and increase agricultural productivity by up to 25%. Similar systems already operate successfully worldwide. In Germany, inflatable weirs on the Rhine regulate navigation and ecology. In Japan, they protect urban rivers from floods while maintaining base flow. These projects demonstrate a common lesson. Distributed, flexible infrastructure often outperforms massive centralized structures. Economically, the difference is striking. A single new mega dam may cost several $billions. A full inflatable dam network on the Karun would require only a fraction of that investment, with a payback period of 6 to 9 years. Construction, operation, maintenance, agriculture, and energy production together create thousands of direct and indirect jobs, spread across the region, not concentrated in one location. The future of the Karun River does not lie in bigger walls, it lies in smarter flow. By replacing new mega dams with adaptive, inflatable structures, we can restore the river, protect the environment, reduce dust storms, generate clean energy, and support sustainable development for generations to come. This is not a compromise, it is progress.